Okay, once again, this is my YouTube channel. You key in energy conversion. There are many videos on energy conversion. Some of them are actual PSLE questions in the past. You can see here this one, and also this one. Okay, just now I mentioned this part because pole vault is something quite interesting. Some prelim question they set this question here, which I show you shortly. Okay, let's look at this question. It's a sporting event. This event is okay. This event is called a high jump. Okay, called the high jump. So you need to show the energy conversion at point X. So point X is the greatest height. So it's potential energy or gravitational potential energy. At point Y is quite easy. So it's kinetic energy. Kinetic energy. So okay, I will fast forward this part. Each. Okay, next we proceed to the more challenging event. This is called a pole vault. This event, the pole vault is very highly technical. It's only in secondary school they have. It's actually quite difficult to perform. Okay, and you need to explain why the landing pad used in this event called a pole vault needs to be thicker than this in the first competition, the high jump. So I'd like to show you one interesting physics video. Okay, can you notice here? This is the 2020, right? River Valley Primary School prelim question 34. This question on the science behind pole vaulting. So you just sit back and relax as I do the screen sharing for this.
And there's the new collegiate record. Mondo Duplantis.
LSU's men's track and field star, Mondo Duplantis, just set a new intercollegiate record for the indoor pole vault, 19 feet 5 inches. There's an incredible amount of physics involved in executing the pole vault, but to really be good, you have to have the speed of a world-class sprinter, you have to have the ability of a long jumper, the agility of a gymnast, and the flexibility of a ballerina. Let's see how he put all of these things together to execute his record-setting jump.
The reigning world outdoor champion from last year in Beijing.
I mean, it's the only record.
It's amazing this actually works just based on simple conservation of energy.
Person is running at a high speed, 9.6 meters per second. So we're going to charge in front and see what's happened.
That all of the kinetic energy starts with ends up going into the gravitational potential energy at the top.
So at the top is only gravitational potential energy.
So Mondo starts about 40 meters back from the pit, runs as fast as he can, in his case around 9.6 meters per second, greatly increasing his kinetic energy. He then plants the bar at takeoff, and it converts that kinetic energy into stored electrostatic.
Okay, this one, electrostatic, is actually equivalent to our elastic potential energy. Okay, this part, the elastic potential energy. So the kinetic energy, as you run forward, as you plunges the pole into the hole, right? Kinetic energy is converted into elastic potential energy.
Potential energy in the bar. The bar then bends and acts like a loaded spring. The bar unwinds, giving him that electrostatic potential energy back into kinetic energy, and more importantly, gravitational potential energy, which then lifts him up toward the bar. And then at the peak, notice how he goes over the bar feet first, and he bends his body into the shape of an L. This actually lowers his center of mass, and his center of mass can then pass actually beneath the bar. This gives him an extra 5 to 7 inches in height, of which he can add to his jump. And since
you see, it's highly technical. It's almost like it's actually upside down on this part, vertically opposite.
I'm someone who's involved in materials research at LSU. This is only possible due to the elastic properties of the material in the pole. If you look at how the men's pole vault world record has varied over the years, around 1920 or so to 1940, it was hanging around 4 to 4.5 meters in height.
Okay, due to the invention of fiberglass, this has helped the world record to increase significantly after 1958. Fiberglass was invented and used in pole vault in 1958. You can see the jump right before that is only 4.5 meters. And then the record shoots up to about this part. 95.5 now have already exceeded 6 meters.
But then in 1958, fiberglass poles were introduced. Now the poles are even more advanced. The fiberglass is reinforced with carbon fiber composites, which make them extremely light and extremely flexible. So they're really good at transferring all of that initial kinetic energy into elastic potential energy and finally gravitational potential energy. So considering how complicated the pole vault is, it's impressive that a simple physics calculation can predict the height of Mondo's record-setting jump.
Good. So okay, so let's review the part which I just mentioned. Okay, come back to the question here, right? That's not this one. Yeah, so energy conversion, that's my YouTube channel. So I encourage you to visit my YouTube channel, this one. So, okay, there's one more I uploaded recently, right? Just to show you energy conversion in Halong Bay. Halong Bay, I encourage you to visit after your PSLE. Okay, after PSLE, go Halong Bay, enjoy this. Conversion of energy from kinetic energy of the motorboat to the kinetic energy of the waves that's being created by the rotating motor blades. And this is Mr. Hao Yu reporting live, Halong Bay, Vietnam. Yeah. So the energy of the waves, as you can see earlier, right? Hold on first, this part. Is it conversion of energy? Yeah, the motor blade is turning, right? So the kinetic energy of the propeller is converted to kinetic energy of the waves, and it also convert to sound energy. There's one more here. This one also energy conversion in a wave pool. This is energy conversion in action. Conversion of energy, electrical energy in the generator room to kinetic energy of the blades under the water to kinetic energy of the water and sound energy. Okay, so you can visit some of this. Okay, this part energy of the blades in the generator room. Okay, the generator room is behind this part. Okay, because if you go to wave pool, you put in your goggles, right? You see below, right? There are these gates. They have this vertical bar. They are actually sweeping the waves. So the kinetic energy, firstly, is electrical energy from the engine room, right? Is converted into kinetic energy of the motor turning, and then the blades turning, then change to kinetic energy of the waves. Kinetic energy of waves change to sound energy as it hits the shore. To kinetic energy of the blades under the water, to kinetic energy of the water and sound energy. Okay, this place is the Civil Service Club in Bukit Batok. I stay about just 5 minutes walk from there. Okay, now it's 5:12. We'll take a short break now before we continue.